Everyone, welcome to another episode. And so today's question, as we can see here, is related to binary search tree. I'm typically not good with tree questions, but like let's give it a try. I mean, max to max, I won't be able to pass all the test cases, but if I do, it will build more confidence in me, right? So let's start with the question. So it says return the root node of a binary search tree that matches the given pre-order traversal. So recall that a binary search tree is where every node, any descendant of node dot left has value less than node dot value, and any descendant of node dot right has value greater than node dot value. Yeah. Also recall that pre-order traversal displays the value of the node first, then left, and then right. Okay, cool. Uh, let's try to understand it through the question, uh, the input that we are given. So 8 5 1 7 10 12. And let me also note, because I don't know the concepts of tree that well. Pre-order traversal displays the value of node first. That means root, and then we have left, and then right. Okay, so this is the traversal. So we are given a pre-order array of the tree. Now we need to construct the tree out of it. So this is a pre-order traversal. So and obviously this is a binary search tree. So the property of binary search tree is that all the values on the right of the root are greater than the root, and all the values left of root are less than it. So let's start with it. So basically what I will do is, because this is a pre-order, I am pretty sure that this 8 is basically the root of the whole tree, right? So 8 comes here. Now what can I do is, I can split the remaining values, which is this, into two halves. One is right and one is left. So all the values less than 8 will be the left part, because we saw the definition of binary search tree that it's going to be less than node value, and for the right it's going to be greater. So I can be confident about this part, that right side these nodes will occur. Right now, once I now let's try to use divide and conquer to figure out the sub problems. Now we have this as the array. So obviously this is uh what do you say, starting value. So this will be the root, right? Oops, sorry, my bad. I didn't took into consideration this value. So 7 is also less than 8. Yeah, looking at the solution I figured out what I'm missing. So now, yeah, now we have a subtree this. So for this subtree, my root will be 5. Automatically 1 will come here, which is less than it, and 7 will come on the right side. And for this, what we will do is, for this subtree, 10 will be the root. Now there is no value less than it, so it will be null, and then this will be 12, right? So this will be our final tree. So yeah, it looks like this. Now how do we approach this? So what we can do is, I guess, let me check the constraints of this problem. It's less than 100. Awesome. So we can go till O of n square solution as well, and O of n cube, but I think we'll find an O of n square. So 8 5 1 7 10 12. Now it's a tree question, so I'm sure that it's gonna be a recursive solution. So what I can do, I can have a function f, and in that function I take um, two things. One is left array, which will be my left half of the array, right array, and yeah, I think that's all I need to provide. And then inside this function I'll check if left array is empty, and right array is empty, so return null. Similarly, I'll create a new node root is equal to new node, right? And then if my left subarray is not empty, I'll call root of left equals to f of, then I'll split the left subarray into two halves, because I would need no, oh yeah, so I think one would be one more value, I would be int value. So this value will be the root value, right? So when I create a new node, I'll create a value here, right? And then I call this function on its left and right subarray, so that I know which half will go to the left side and which half will go to the right side. um, yeah, and obviously there will be a for loop here to separate the values out from, and I can pass in the index value of the array as well. And let's pass in the yeah, instead of wait, this has got dirty. Let me take a new screen. I think I was doing wrong. What I can do is 8 5 12, right? Now this is array A. What I'll do in my function, I'll pass array A, I'll pass int head value, which will be 8 in our case, and A is the remaining array, and then int index. In our case, initially when we call this function from main, it will be this array 5 1 7 10 12 comma, and this is the array comma 8 comma index 0. This will be called. Now once this is called, if array is empty, so I'll return null, right, without thinking. If yes, if that is empty, I'll return null. If now what I'll do, yeah, now I'll iterate for loop and split the array into left and right half, right? Now once I do that, I'll call the root of left on the equal to on the left half of the array, right? I'll increment the index, so my head value would be, actually I need to pass the head value. Yeah, I can pass the head value, which will be the starting value of the left array, or there is no requirement. Actually, yeah, there is no requirement of this value. Index, yeah, actually index could also be avoided. So let's look into the code. Actually it will be more clear. Sorry for my bad handwriting. So I'll create node traverse, and I'll just focus on vector int a, right? If a dot size right, and then I'll create two vectors, left array, right array. Obviously the first element of the array A will be my root, right? So what I'm gonna do is I'm create and here tree node with the value a of 0, right, because a is not 0. And then what I'll do is I'll start a for loop I less than a dot size. If the values are less than a, I'll insert them in the left array, else I'll insert them in the right array. Right, if a of I is less than, does it say evaporated? Is a pure or distinct? Awesome. So I can just check with the a of I, else if they are greater, then it will be the right side. Of I. Okay. Now what I can do is, if my left array dot size is greater than 0, right, then only I need to iterate on the right side, on the left side. So root of left value will be I'll call traverse on left array, simply left, right. If right size is greater than 0, do root right is equal to, and we'll just return the root, right? So what I can do here is I'll just call return traverse on pre-order, right? Let's run this and see. I'm doubtful it will successfully run on the first attempt, but seems to be working. Let's see. Awesome. Okay, I guess the approach was clear from what I did in the code. Like basically I split into two arrays and I just call the left and the right half of it if its size is greater than 0, because of the binary search property where all the left sides are less than the root, right? So, and because it's in the pre-order format, the first element of the array is going to be the root of that tree, right? So when you go, so basically I'm trying to divide and conquer. So when I go on the left side, the whatever left array is, the first element will be the root of that subtree, and similarly for the right case. Hope you guys like this video. If so, subscribe to my channel and give me a thumbs up. Thanks everyone.